All right, guys, this is Miss Reisinger here, and I am going to go ahead and walk you through how to do a chi-square test of independence. I'm going to use our notes, which is example number 3 that are from this week, and we're going to walk through the steps, and you can see me literally use the calculator at the same time to run the chi-square test of independence. So you should hopefully have out your recipe card, and you should be on the back side where we have chi-square test of independence, 2 or more variables. Now this is our standard recipe card. We have been doing this for a while, so remember step 1, we're going to write out our hypothesis. So in this example it says we're determining whether a combination of childhood abuse and a certain abnormal gene are more likely to commit violent crimes. And we have a study where we are running in a simple random sample, remember, otherwise known as an SRS, of 575 males in the 25 to 35 age group. Now remember, these are set up as tables. So you need to start thinking of these as a matrix or a matrice, as we will be using that later on in our recipe card. And so this is going to be considered a 2 rows by 4 columns. Hence why it's going to be a 2 by 4 when we actually get to the steps to put it into the calculator. Now, sometimes I will give you a separate table as you saw in examples 1 and 2. For this example, I did not give you an extra table, hence you're going to see extra writing and I'll go over what those are. So we know null hypothesis. Remember, we need to talk about what variables are being compared in this situation. And since we're talking about 2 different variables, and we're talking about the genes here, we're comparing behavior, somebody's behavior, and if they have the gene, those are going to be our 2 variables. So we're going to write our null hypothesis, the behavior and gene are independent. And then your alternative is taking the same exact genes, same exact variables, and now inserting the word are associated and are not independent. Now, when we do our step 2, you know, as required, I ask you to write out the formulas. So we have x squared equals the observed minus the expected squared. That's in parentheses divided by your expected value. Now, step 3 has a check because it says you're going to calculate and list the expected values. So if we take a look at our recipe card, we're right here at step number 3. And we're going to right now use with the calculator our second matrix edit A. So second matrix is with the x raised to the -1 power, the inverse. So -1. We're going to go over to edit. We're going to use option A. And now I'm going to change that as we see in the previous set of notes. It is now a 2 by 4. So I'm going to say 2. Oops, sorry guys. We now have a 2 by 4. And we'll see once I hit enter, we now see the 2 by 4 grid as we then see compared directly with our notes. Now this is going to advance across when you press enter and type these in. So I have 48, 48. Then I'm going to type in 21. So we're going to fill in our table based on the values we have. 201, 79, 118, and 50. Whoops, I do have an error. So I have 118, and that should say 50. Again, you know me, I will make mistakes as well. So this is where I always ask you to double check your work and see what you have. So you'll hear me briefly comparing, making sure everything matches to what I have on my screen and that are contained in my notes. Now this is our, again, calculating and listing the expected values. So looking at our card, we did our matrix, which again was a 2 by 4. It says do not include totals, so we don't include that. We're now going to press second and quit, which is your mode button. Again, blue function. So second quit. Now we're going to go to stat. We're going to go over to tests. And then notice I want you to find letter C for the test to run, which is just an x squared test as compared to our previous set of notes, which was the goodness of fit, in which we used option D for GOF test. So I want option C. I'm saying that I want it to compare the observed to the expected. We put all of our data into A moment ago, and I'm saying I want the calculations for the expected into column B. So go ahead and keep these exactly the way it is because you should have an A and B. I'm going to go ahead and calculate. And there we go. Yes, you know with your recipe card, I expect you to plug values. Now here's the thing on a chi-square test of independence. Notice I did not have you really go ahead and write out the equation. The reason why I didn't have you write out the equation because I could say use the first and the last one like I did with the Goff test. But here people mix up like which one is Miss R asking you to go ahead and use as the first equation and which is the last equation. So that's why I don't ask you to do the equation here when it comes to a test of independence. Now again, that's why I tell you to look at the table because on our recipe it says to list out your expected values. So as you can see, we don't see the expected values, which are these values in a bluish green color. We do not see them. So we'll get to that in a moment. But I'm going to take the time and put on 4, look at the table. I'll come back to that in a moment. Step 5, we know we write out what does x squared equal. In this case, 7.75. If you write 2, we have done the typical rounding the 3 decimal places. That is perfectly fine. Again, our p-value, we do round to our 3 or 4 decimal places, so 0.051 in this case. Now, in this particular problem, there was not a given alpha or a level of significance, so we will continue to use 0.05. And notice it's already calculated your degrees of freedom. Okay, so your degrees of freedom were calculated for you, and we already know that answer is 3. Now, when we compare, we still will know that when we actually compare it in step 6, again, back to recipe card, when we compare it, if the p-value is less than the alpha, we'll reject. If it is greater than alpha, then we will fail. In this case, the p-value, and again, I tell you to think of it like money. This is right now 5 cents, and this is 514. Add on 2 extra zeros, so we would have $500, or would you rather have $514? I think we all know we would rather have $514, so P is greater, and therefore it is a fail to reject. Now I still haven't inputted these expected values, so the question is, how do we get those expected values? Well, here's how we're going to get the expected values. You're going to go back to second, and you're going to go to matrix. When you go to matrix, look, suddenly, now you have 2, number 2 filled in, and it tells you it's a 2 by 4. Well, I want that. I'm going to first go over to edit, and I want to see what is there. So yes, I must be in edit to view it, and I'm going to press enter, and there are the expected values. So if you notice and see the notes, we have 54.997. Whatever is on the screen, write down those values. Do not start to go ahead and round whatsoever. Just write down what the expected values are. Realize all these observed values totaled 127 if you took the time to add up these expected values across for criminal behavior, they would also add up exactly to 127. So realize all values between expected and observed will still add up to the same thing. So again, to get to the expected values, since we didn't just get it, let me get out of this. I would go ahead and hit second matrix. I'd move over to edit. I now want B because we said make that the expected values. And we can see the expected values. Last step, as always, is to go ahead and write our conclusion. We have a decision to make. Are we going to reject or fail? A moment ago we said fail, so we're going to list what our p-value is. So our p-value is, I have slightly forgotten, 0.0514. We failed to reject the null. Again, we're just following and filling in the blank. There is not sufficient evidence at alpha equaling 0.05 to suggest that the behavior and gene are associated and are not independent. Notice I messed up, hence I inserted my associated and are not independent. I hope this helps you to figure out how to do a chi-square test of independence. Again, we use the test of independence when it deals with 2 or more variables.